You've seen the videos, right? Robots walking, working, even doing backflips that I definitely can't do. For so long, this was just science fiction, but now it's suddenly becoming very real. So what's actually driving this incredible explosion in robotics? Well, today we're going to break down the AI revolution that's giving these machines a mind of their own. So let's get right to it. Why now? I mean, for years, humanoid robots have been a cool thing in a research lab or a blockbuster movie. But all of a sudden, they are all over our feeds, getting tested in actual factories, in actual warehouses. What on earth changed? The answer might actually surprise you. Because while the motors and the joints and all the physical stuff has gotten better, for sure, the real breakthrough, the huge shift that is unlocking this entire industry, it isn't happening in the hardware. It's happening inside their heads. We are witnessing a full-on revolution in the robot's brain. Okay, so if it's all about the brain, what exactly is inside it? Let's pop the hood and really unlock the core technologies that are giving these robots their smarts. First up, we've got large language models, LLMs. You can think of these as the robot's mission control or its high-level planner. See, instead of programming every single tiny movement, you can now just give a robot a simple command in plain English, like, hey, can you go grab that wrench for me? The LLM figures out what that means and breaks it down into a logical plan. Okay, first find the workbench, then identify the wrench, plot a path to it, figure out how to grip it, and bring it back. It's an absolute game changer. All right, next, the robot has to be able to see, and that's where advanced computer vision comes in. This is basically the robot's eyes, giving it a full 360-degree understanding of everything around it. And we're not just talking about seeing an object, it's about recognizing what it is, how far away it is, and mapping out the entire room all in real time. This is so critical if you want these things to work safely in messy, unpredictable places, like where we live and work. But what about actually moving around? Walking is hard. That's where reinforcement learning, or RL, is just magic. The best way to think about it is it's like teaching a toddler how to walk. You don't give them an instruction manual, right? They learn by trying, falling, and trying again. It's the same idea here. Robots are trained for thousands and thousands of hours in these super realistic simulations. They get rewarded for good moves, like staying balanced, and over time, they literally teach themselves how to walk, how to run, and how to handle tricky terrain. Now, when you put all of this together, you get to the biggest paradigm shift of all, foundation models. You should really think of this as the ChatGPT moment for the world of robotics. Instead of building a brand new AI for every single little task, companies are now building one giant pre-trained model on just enormous amounts of data. This one brain, like the one Covariant AI is building, can then be put into thousands of different robots to do all sorts of jobs, from picking parts to sorting packages, without having to start from zero every single time. So, we've got the tech, we have the brain, but who is actually putting these brains into bodies? Well, this whole AI revolution has kicked off this really fierce competition between some of the biggest and most interesting names in technology. We've got major players like Tesla, Figure AI, the legendary Boston Dynamics, and Sanctuary AI. And what's so fascinating is that they are not all following the same playbook. Each one is making a very different strategic bet on how to build the smartest robot. And this really highlights the central debate happening in the industry right now. On one side, you have Tesla making this huge, ambitious bet on a vision-only approach. They believe that the massive amount of camera data from their cars is enough to solve robotics. It's cheap, it's scalable, but it is risky. And then on the other side, you have companies like Figure AI, who are fusing together multiple sensors, cameras, LiDAR, touch sensors, to get a more complete and reliable picture of the world. It's critical for safety, but it could be more complex and expensive. And then, of course, there's Boston Dynamics. That famous Atlas robot that does all the parkour, it's not actually a product you can buy. Think of it more as a research platform that's designed to solve the absolute hardest physical challenges first. By just pushing the boundaries of what's possible with agility and control, their breakthroughs end up pulling the entire industry forward. Innovation isn't just about the tech itself. It's also about the business model. And this is where Sanctuary AI is doing something really interesting. They're pioneering what's called Labor as a Service. So instead of buying a super expensive robot, a company can just hire one for a specific job. This completely lowers the barrier to entry, and it could be the key that finally unlocks widespread adoption for everyone. So why is all of this happening with such incredible urgency? Well, it's not just a technology push. There is a massive market pull that's dragging this future into the present.
First, let's talk demand.
Projections show there's going to be a global shortage of nearly 8 million manufacturing workers by 2030. That's not a small number. That is a massive economic hole that companies are desperate to fill. For a lot of them, automation isn't a luxury anymore. It's becoming a question of survival. And of course, where there's that much demand, the money follows. Goldman Sachs is projecting the humanoid robot market could hit $38 billion by 2035. To put that in perspective for you, that is bigger than the entire global market for video game consoles is today. This isn't a niche experiment anymore. It's the next major economic frontier. But here's the number that makes it all click into place. The target cost for one of these robots is about $50,000. Just think about that for a second. When the one-time cost of a robot that can work 24/7 gets close to the annual cost of a single human worker, the whole economic equation just flips on its head. For thousands of businesses, the choice to adopt these robots becomes almost inevitable. And look, this isn't just theoretical someday stuff. These robots are already being put to work. Figure AI is working with BMW, Boston Dynamics is working with Hyundai. They're being tested right now for everything from logistics in a warehouse to, down the line, helping with patient care and even managing inventory in retail stores. But hold on. The path from the factory floor to our front door, it's not exactly a straight line. The journey from these early tests to mass adoption is still filled with some pretty big challenges. Yeah, while the AI brain is advancing at this just incredible breakneck pace, we absolutely cannot ignore the very real technical and ethical roadblocks that are still standing in the way. Probably the biggest issue is what people call the hardware bottleneck. Basically, the software is writing checks that the hardware can't always cash yet. Robots still really struggle with delicate, fine motor tasks. Battery life is a huge problem if you want them to work a full shift. And of course, the cost of today's prototypes has to come way, way down before they can be mass-produced. And then there are the big societal questions that we need to start talking about right now. We need to have serious conversations about job displacement. What about safety and accountability? I mean, who's responsible when a robot messes up? There aren't specific OSHA standards for this yet. And what about the privacy implications of having these things in our homes and our workplaces? But even with all those challenges, the predictions are just incredibly bold. The prominent venture capitalist Vinod Khosla believes that by the 2030s, pretty much everybody will have a humanoid robot at home. Let that sink in. That is less than a decade from now. Which leaves us with the ultimate question, doesn't it? As we get closer and closer to perfecting these artificial brains and building these incredibly capable bodies, what is it that we're actually creating? Are these partners designed to work alongside us and take on the jobs we can't or don't want to do? Or are they something else entirely? That's the question we are all going to have to answer, and probably a lot sooner than we think.